Hello, I'm Mr. Milani, and today we will learn how to manipulate formulas, also known as solving for the unknown or solving for x. Now, I'll assume that if you're watching this video, it's because even though you were taught how to, solve for x or solve for the unknown in math class, the kind of math way of doing it isn't 100% with you, that you're still a little fuzzy. And this way, I think, is a good way to learn how to do it for people who just don't click with the math way. And to be honest with you, it's the way that I manipulate formulas and have for a long time. What I noticed is in college, after having done a ton of formula manipulation the math way in high school and college and all the courses there, I found myself doing it this way just because it was quicker and I was comfortable with manipulating the formulas, knew where I was going to get to anyway, and it got to the right answer. I just skipped some of the steps, and so think of it more as moving furniture rather than doing math. And I think you'll find it's a pretty easy way to go about things. All right, there's one quick caveat or one thing to be aware of about this, which is that if you look at a formula that has a plus or minus in it, like if we take the slope formula, y is equal to mx plus b. Learn that in math class, geometry for sure. Who knows if it was algebra? Anyway, what what this method is, I will teach it to you today. It won't work if there's a plus or a minus in the formula. There's a way to make it work, but we'll talk about that in a moment. But for today's lesson, I want to keep things simple and uncomplicated. So I will teach you how to do it if there's not a plus or a minus, because pretty much all of chemistry's formulas do not have a plus or minus in them. So we'll keep it simple today, but once you get comfortable with this, once you get bulletproof on this process, just come see me, and I will be happy to kind of show you the one extra step to add, and you'll be able to do that with all formulas, including those with pluses or minuses. But for now, with what we learned today, please understand that you can't really do it yet if there's a plus or a minus in the formula. Okay, we'll start with the basics. Now you may think, hey, you're really underestimating me, but take a look at the person next to you. I gotta start at the very, very basics, right? Not a shot at you, it's a shot at them. No. All right, just kidding. Now recognize that a variable or a number can only be in one of four spots. One of these four spots. And it can either be numerator up top, or it can be a denominator down on the bottom. And then also it can either be left of the equal sign or it can be right of the equal sign, right? So we have four different spots they can be. And so what we're going to do is kind of keep that basic idea in mind as we go about our method. Now here's our four different boxes. And so we can see here with this example where we know that 1/2 is equal to 4 divided by 8, or 4 divided by 8 equals 1/2. It's pretty simple to see that the 1 is a top left box and the 2's in the bottom left box. Let's try that again. 8's in the bottom right box and the 4 is in the top right box. So the four boxes are pretty easy to spot here. So that's pretty simple, straightforward. Now, if we take a look at this one, however, the ones on the right are easy to figure out, but take a look at that. We just have a whole number for a 2. Now, recognize that what we're doing here is we're just assuming, and algebra does this, is that it's our 2 is being divided by 1. And so there's just an implied 1 that's missing when you write the 2 like this. For our purposes, what I would like you to do in chemistry and formulas is just say, hey, the 2's in the top left box. 8's in the top right box, 4's in the bottom right box, and then there's just an empty box down here. It's fine for it to be empty. And so think of it that way. We don't need to worry about the 1 since it's really mathematically irrelevant for us. All right, so adding in unknowns to the exact same idea. Here's the examples. Now we have x divided by 2 is equal to 4 over 8. Or 2 is equal to 8 divided by x. So a couple things to just point out real quick is that we can see that our unknown in this case is on the left. And in this case, our unknown is on the right. Our unknown in this case is on top, and our unknown in this case is on the bottom. So really what I'd like to point out to you is that our unknowns can be in any of these 4 boxes, and we just need to know how to handle it in each case. All right, same exact thing, same exact concept, only now let's move on to formulas. Now, this is a formula that you probably don't have any clue what it means because we're not going to teach it to you until next semester. This is a gas chemistry formula, and the nice thing about formulas is that you don't need to know what the variables mean in order to solve for them and solve the problems. In fact, AP Chemistry is getting away from testing people on formula work because they're trying to make sure that students are learning why things are happening and how they're happening, not just mechanical punching numbers into a calculator. Because you can solve this answer, let's say if you had all the numbers except for n, and n is your unknown, using this method I teach you today, you could solve for n and get the right answer without even knowing what n stands for. So it will serve our purposes today to use the formula and just recognize that we'll learn the details of it next semester. Now, the reason it's good to learn the math part now is because second semester things are more difficult. And if you're bulletproof on the math by the time you meet the second semester formulas, then you can focus all your effort and attention on comprehension of the new stuff and make things a lot easier for yourself. So that's why I am starting you early with the math, even though we don't really use formulas until next semester. All right, so P equals nRT. We can see then that P and V are in the top left, nRT are over here on the right. Notice it's perfectly fine for there to be more than one variable or number in each box. Here we have 3, and over here we have 2. And it's perfectly fine for boxes to be empty. So just be comfortable with that. Next, we have M equals N over L, again a second semester formula. And as we talked about with the 2, this is how we're just going to put this into our formula, into our ideas. The M being all alone is not part of a fraction, so therefore it's in the top box over an empty box, and N over L are like so. And finally, I think this is the most complicated formula in chemistry, general chemistry this year, because it has 6 different variables and they're both, fractions are involved. But for today's purposes, it's actually pretty simple because we are able to easily see and put them into our 4 boxes. They're nicely separated for us. Now, a quick little note. Note this P1 here in this format and this P1 here in this format. It's the exact same variable. I just was able to use subscripts on this side right here. Let me put the 1 as a subscript. That's where it's down below like that. I will do that every time I have a chance to do so. But back over here, when I'm inserting into a fraction, you can't do fraction and subscripts. So just recognize that it'll come at you 2 different varieties of the exact same variable. Means the same thing. Just wanted to get that out of the way. All right, so now we've seen how to put all the formulas in the boxes. Now let's figure out how to move them and manipulate them and actually solve for x. So we've done the basics. And hopefully it's pretty easy. And if it thinks pretty easy so far, then I've got good news for you because it doesn't get much harder. Seriously, it's pretty darn simple. How do you do it? There are 3 rules to follow. 1, our unknown has to end up in a top box. 2, everything other than our unknown has to be on the opposite side of the equation from the unknown. So this gets to our goal. Our goal is to have the unknown in a top box all alone and everything else on the other side. And then to make that happen, the things can only move diagonally across the equal sign. So that's basically the rules. And if you can remember that, that's all you need to remember in order to solve for x in chemistry and most physics formulas and basically most business formulas. And once you get 100% comfortable with it this way, see me, 5 minutes, you'll be able to do it with every formula because we'll just add in that one extra step. All right, let's do it. Here we have our 4 variables. Now, they are, oh darn, okay, so if something is starting in the top left box, it can only move down to the bottom right box. Now again, we're not going to want to move the unknown. If it's in the top box already, we're not going to move it. And notice how this is crossing the equal sign. So this is the equal sign I'm blurring in right here. There's a down diagonal across the equal sign. So anything other than the unknown that we need to move away, if it's in this top box, it'll move down to the bottom right box. And if it's in the top right box, it'll move down to the bottom left box. Bottom left box moves to the top right. Bottom right box moves top left. So very simple idea. Every one of them just crosses the equal sign, and we're just moving furniture, as I said. All right, so let's apply that to our formulas. Let's prove in real formula application. So if we have PV equals nRT and are asked to solve for P, that's our unknown, then the first question we always need to ask is our unknown already in a top box? Because if the unknown is already in the top box, we're not going to touch it. We'll just leave it alone. But if the unknown is in a bottom box, we need to move it first before we do the rest of the stuff. So that's our first question, is where we start. Then once the unknown is in the top box, or if it already started off in the top box, we're going to move everything that's on the same side as the unknown to the other side. And remember, if it's already on the other side, leave it there, and things can only move diagonally. So we have our PV equals nRT. Remember, there's the boxes, and let's go. So here I put PV equals nRT, made it bigger, and you can see that I've put the unknown in white and all the others that are not the unknown, they're knowns, into black text. And so our first question is P in a top box? Yes, it is. So we're not going to touch P, but instead we're going to move on to the next step, which is to make sure that P is all alone by moving everything that is on the same side as P right now to the other side. Here's the side, and if we look, then V is the only thing that's on the same side. So we're going to need to move V away from P to the other side, and it can only move down diagonal, and we do so, and there's the final answer. P is equal to nRT divided by V. And this is the answer your math teacher would come up with if you put this formula in front of them. So it's mathematically valid. It's just easier to just move it than really sit there and do the math properly. It is that simple. Now, let's do it again. PV equals nRT, only this time T is our unknown. And here's what I'd like you to do. Let's have you pause the video when I say, and I'd like you to solve this, write down the answer, and then unpause the video, and we'll check and see if you got it right. You know everything you need to know in order to do this properly and to do every formula properly. In fact, it's just a matter of practice. So pause the video now, and I will sing Jeopardy. Okay, if you're paused, I'll just pretend I sang the whole Jeopardy song. In the meantime, welcome back. You have solved for T, and if your T answer, if you got this, T is equal to NR over PV, you got it wrong. But the good news is, if you got it wrong, then I know why you got it wrong, and we can fix it. The reason I do see this fairly often, and the inclination for people is to always kind of have their unknown be on the left, so T is equal to something, 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 something. And because of that, people end up, the T was right here, right? And so T, you moved it to the left, and then you did your manipulation the way you're supposed to. But if you remember, there were only two rules. There's actually only one rule, and that's that things can only move diagonally. And if you got this wrong, you missed the one rule. Is that too many rules? Is one rule too many rules? I wonder. So no problem. You won't make that mistake again. I know. But just get comfortable. Here's the problem. This error only happened because you wanted your unknown to be on the left and everything else on the right. Get comfortable with your unknown being on the right and everything else being on the left. Don't think left, right, in fact. Think top, bottom. That's all that matters. If your unknown's on the bottom, you got to move it to the top. If it's on the top, you'll leave it alone and then just move everything else away from it. So once you're comfortable with that, you won't make this mistake again. And there's only one other mistake I see people make who don't do it in their head. Always write the formulas down and then work with them. I'll do that. We'll do a separate video on this. But that other mistake people make, I think we've eliminated just by explaining the boxes properly. I won't get into it, but I think that will never appear again. So I think that's good. So get used to the unknown being on the right. You won't make this mistake. Good. All right. So I took the N and R from here and slid it straight down to there. And I moved them together. I'll explain that more in detail with the next slide. Okay, so here we have our complicated formula. And it is more complicated, but really it's not any more complicated because we're going to do the same thing that we do with any of the formulas, and it just looks more complicated. So what I'd like you to do again is pause the video, solve it yourself, try it on your own, and then you'll be able to compare your answer with the right answer, which will be my answer, and see if you got it. And if you get this right, you can do anything. You can dodge a wrench. All right, here's the video. I'm going to pause it now. Here's the formula and Jeopardy theme. All right, I will assume you have correctly finished the problem on your own, solved for T1. So let's walk through it. First question is our unknown on the bottom? Yes, it is. It's right here and it's getting all yellow. All right, so what we need to do then is we need to move the unknown first, like so. And we do that, and we get that, and this thing kicks in right away. That's okay. Now, our unknown here, T1, is now in a top box. So since it's in a top box, we're at the step of moving everything to the other side away from our unknown so that it's all alone. Let's make it yellow again. That was kind of fun. All right, so our unknown will be all alone soon, and the way to do that is by having T2 go from here to the top box, like so. Now, we have T2 as in the top box. I'm going to move P2 and V2 together down here to the bottom in one step. I'll just move P2, V2 at the same time because it's quicker. You can do it one at a time if you want, but there's no point in doing it one at a time when you can just go bam, move them both together like so. And so we end up with our unknown T1 is equal to T2 P1 V1 over P2 V2. Now I'm going to take a minute here and teach you one extra bonus thing. Okay, here we go. First thing, notice the T2 is here. And some people say, hey, I put, oh, that's a bad color. I put T2 over there on the right. Does that matter? And the answer is no, it doesn't matter. If you put the T2 here instead of over here, you'll still get the same answer. This is some, I don't know, commutative theory or one of those three things that I learned a long time ago and forgot. But basically, this times this times this equals the same number as this times this times this. It doesn't matter the order. So it doesn't matter where you put the T2 or what order you have them. Now, that's question one. Now, the other thing, let me explain the big picture here. What this tells us, where's my mouse? There it is. What this tells us is that T1 is equal to T2 times P1 times V1 divided by P2 times V2. Now, here's where I save you from a mistake. If you put into the calculator T1 and you have all these numbers, there's actually everything on this side has to have a number, like 12. If you put those numbers in the calculator and said T2 times P1 times V1 divided by P2 times V2, you're going to get the wrong answer. And the reason is because of order of operations, this math rule things, basically you have to put these in parentheses if you do it your way. Well, you would have to say T2 times P1 times V1 divided by parentheses P2 times V2 equals T1. But here's why. As a reward to you for listening this long, I will give you a pro tip. Here's how you can do this properly in a calculator without having to use parentheses. Take T2 times P1 times V1 divided by P2 divided by V2 equals whatever the calculator says is your answer. So if you hit divided by before every number you enter on the denominator on the bottom, you don't have to do parentheses and you'll get the right answer. So bonus pro tip there. Hopefully that did well for you because that's it. That was the hardest example I could think of in chemistry. 6 variables, unknown was a denominator, and we did it in under 25 minutes. Now, hopefully this was useful to you. I promise you will use this a million times in chemistry and maybe physics and more. It will be useful. So thank you. I will talk with you next time.